Welcome to Build Tick Tinker. My name is Mikael Sjöman and I am attempting to build that thing over there, which is an electric DIY 3D printed carbon skinned electric outboard that I have been building for the last couple of months. And in the previous episode I had an issue. So I have a carbon fiber wing that I'm trying to connect to the boat through a hinge here, as you can see. And when I put pressure on with bolts here, you can see what happened. And the issue is that when you print ABS, which this is in my 3D printer, what happens is that for each layer that you print is kind of printing layer by layer by layer by layer, and when it goes up it builds up a tension, because when the plastic cools for each layer kind of builds up kind of a pressure like this. And when I put a bolt through here, what happens is that the bolt was pushing inwards, of course, exactly at the end, or with this, I don't know. Yeah, anyways, it's the bolt pushing inwards, and you can kind of see it delaminating here. So I've been thinking hard on how to solve this. In the previous episode, I was pretty darn sure I was gonna try to order from Cheedy this glass fiber ABS, because what happens is that these small micro glass fiber strands, it would kind of block this pressure to build up this problem. But it turned out that I had a roll of PETG, which doesn't have the same warping problem as this is, because PETG doesn't really shrink as much as an ABS does. So I reprinted this, as you can see. Let's see if I can get it there. You can see it down there. There, it's in PETG. I'll give you a better look at it soon. And I reprinted this, and definitely way better, I mean, layer adhesion, this is called. But I'm still dead scared. What if it happens when I'm out testing this darn strong motor and it delaminates and the bolt goes straight out? I mean, it didn't go through the bolt hole, but it just doesn't make me feel good about this. So I was thinking about the solution, and the solution I came out with was kind of to print this whole one with kind of wings going out. And what I'm planning on doing is taking a big part like this that has this kind of profile. Let's see, from this side. And I'm gonna thread this over like this, like when it's together. See, like this. So we kind of get it all over like this. And the idea is to put this on tension, so the problem is that the plastic will go like this. But if I could put the plastic into tension, my hope is that there is no way for this to really happen, because if it's pushed inwards, this pressure that it wants to delaminate, even if it delaminates, it has nowhere to go. So what I did was that I sat down a little bit and thought about it, and then I 3D printed this big one that when we pull this over here, but remember that part looks different, it actually has wings coming in, locking in that position. Then it stops up here, and then I can push this into position so that the plastic has absolutely nowhere to go. And that would kind of stop it to go in this direction, because of, yeah, you could imagine that there's two small wings going out that matches this kind of pattern in there. So it can go this way, and it can also, and the main thing is that even if that would happen, what would happen is that, let's say it actually delaminates and this part jumps off, I would still kind of have a ring going all the way around. In the 3D printed, this is 3D printed in this direction, but the new part goes like this. So it's 3D printed in a 90-degree angle. And since it's printed in a 90-degree angle, it can't really disconnect. It's, I mean, it has those wings blocking it running out, and that also means that it would stop the bolts from falling off. So I have 3D printed these holes in here. I have to print a new part because I can see that it's not strong enough. But I will make it a little bit heftier here because of the holes that are threaded. So I 3D printed them in place with threads. It's wonderful what you can do. And these stick like crazy. If I take these in, okay, I won't see that one, but yeah, there we go. So in here with this, I can just take a M5 screw, and my god, I mean, you cannot pull this apart. It's gonna be super strong. So the idea is that it's a little bit too short, this big part, so these will kind of push together so that it kind of locks all the plastic together. So I'm not going with the 3D, I mean the glass fiber ABS for now. I reached out to Chidi and asked them actually if they want to kind of sponsor an episode where I test this out on this big functional parts. I think this is like the perfect use case for it. And yeah, so you can kind of see how this is kind of lock it in, and the bigger part, let's see here. There we put it. This one, it would kind of lock the whole thing in like that. And I'm just hoping that, I think this is actually a good safety measure. It's after all, I think it would hold even with that, what I've done, because I've done one more trick and I'm going to show you that. Let's do it now. So we are back here. I have reprinted this one in PETG because ABS has this warping tendency that each layer kind of contracts inwards and creates a lot of internal pressure. And PETG doesn't have the same issue. So that's kind of nice. So I reprinted this in PG to PETG. A little bit scary still for heat, how that's gonna handle, but yeah, let's see. Then I know that when you push these together, the layer lines under this gets a lot of pressure, but the ones outside here don't get. So through one layer line here, and that's where it cracked before, that's where it kind of blew. So I put this one over here to kind of distribute the load so that there's not one layer line getting all the pressure. Then I took and reprinted, when I reprinted this, created these kind of wings out here. And the idea there is that I will be able to put something like this, and it's printed actually in this direction because I want it to be like a U-lock around here. This kind of slim thing you see here, I want it to lock around here so that the plastic that maybe wants to go outwards is holding to compression. So I didn't print it like this, like a lock, like kind of biting inwards. I put it like this. And lots of iterations later, lots of plastic, probably half a kilo or more, probably more. I had white, I ran out of white, and the final one looks like this, with heated inserts, both inside here and here, because I was totally wrong. I tried to make this video, I was like, yeah, it will hold up, no problem. You just make threaded inserts in M6 and it'll hold. No, it doesn't. I pulled and they went off. So I now have heated inserts, knurled inserts inside these. And as you can see, it comes down here. Let's see. Oh. Yeah, let's hammer that down. Woohoo! And it's actually angled inside there too, to make sure that it's actually always in contact with plastics. So the final thing to do here is to connect this one from under, and the trick here I'm trying to make is that it's a little bit too short here, as you can see. So these screws will kind of put this kind of U-lock in compression to hold everything together. So even if this breaks, everything is held together. It should not be able to move. And I kind of like this new handle thing because it will make it much easier to transport. Still have an issue with this one, kind of. Let's see what I do with that. But yeah, getting closer to done here. I have put the electronics in. That's the next video coming up. But I wanted to make sure that safety was taken care of. And I got a handle for free. Doesn't that look great? Let me know. I think it's starting to look pretty neat. I like it. So, if you like what you see, like and subscribe. I'd love to get the help from you guys, and especially give me some comments if you see me doing something weird here that could be dangerous. I really appreciate the comments I had got, and that really helps me improve the design. Cheers!